In this video, I am about to prove SSC General Math Chapter 8 Example Theorem 17, 18 and 19 and 2 number theorem from exercise 8.1. Actually, these 4 types of theorems are similar to prove. If we can prove two triangles congruent, then these 4 types of theorem can be easily proved. So let's begin. In example theorem 17, it says that the line segment drawn from the center of a circle to bisect a chord other than diameter. First, try to understand what does mean by the chord other than diameter. If this is a circle and this straight line is diameter of the circle, this diameter we also call the biggest chord of the circle. So here we cannot take any diameter. We should take a chord other than diameter. Suppose AB is a chord other than diameter and M is the midpoint of AB. If we join OM, then we should prove that OM perpendicular AB. It means angle AMO will be equal to angle BMO and both of these angle will be 90 degree. Now come to particular enunciation. Let ABC is a circle with center O, where AB is a chord other than a diameter and M is the midpoint of AB. Join O, A. It is to be proved that the line segment OM is perpendicular to the chord AB. Now come to drawing. There is a question that when should we write drawing? Actually, after writing particular enunciation, if there is something extra to draw to prove the theorem, we should write it in the drawing. If you look here, there is no triangles here yet. As I told you, we need two triangles to prove congruent. So to get two triangle, we should join OA and OB. Come to prove it. From triangle AOM and triangle BOM, we have OA is equal to OB. This is because they are the same radius of the circle. Second, we have AM is equal to BM. This is because M is the midpoint of chords AB, and OM is equal to OM because OM is the common side of both triangles. So to prove two triangles congruence, we have three conditions here. So we can say triangle AOM congruent to triangle BOM. When this is the case, we can say this angle will be equal to this one, like angle AMO is equal to angle BMO, and both of this angle will be 90 degree. If I take a straight line AB, we know a straight angle is equal to 180 degree. So if I divide this angle into two equal parts, each angle must be 90 degree, because 90 degree plus 90 degree, it will be 180 degree. So we can say both of this angle is 90 degree. When this is the case, we can say OM perpendicular to AB, and this is our final proof. Come to the theorem 18. It says all equal chords of a circle are equidistant from the center. First, try to understand it. If this is a circle and if we draw several chords like A, B, C, D, E, F, if all these chords are equal, then we should prove that all these chords will be equidistant from the center of the circle. We take a circle A, B, C, D with center O, where chords AB is equal to chord CD. We draw OE perpendicular to AB and OF perpendicular to CD. Then we should prove that OE is equal to OF. Now come to particular enunciation. Let ABCD be two equal chords of circle ABDC with center O. It is to be proved that the chords AB and CD are equidistant from the center of the circle. Come to drawing. To get two triangles, we need to join CO and AO. Now come to prove it. Here we have AB is equal to CD. It is been given. If we multiply half both sides, we will get half AB is equal to half CD. Instead of half AB, we can write AE, and instead of half CD, we can write CF. This is because we know the perpendicular line drawn from the center bisects the chords into two equal parts. So from triangle AOE and triangle COF, we have AO is equal to CO. This is because they are the same radii of the circle. AE is equal to CF. We can write it from there. And finally, we have angle AEO is equal to angle CFO, and both of this angle will be 90 degree, as we have drawn this here. So to prove two triangles congruent, we have three conditions here. So we can write triangle AOE congruent to triangle COF. When this is the case, we can write their similar side will be equal, means OF will be equal to OE. Chord AB and CD are equidistant from the center O, and this is our final proof. Now come to theorem 19. It says chords equidistant from the center of a circle are equals. Suppose A, B and C, D are two chords. If we draw perpendicular line OE and OF to the chords AB and CD respectively, then we should prove that chord AB will be equal to chord CD. Now come to particular enunciation. Let AB and CD be two chords of a circle with center O. OE and OF are the perpendiculars from O to the chords AB and CD respectively. If OE is equal to OF, it is to be proved that AB is equal to CD. As we need two triangles, we should join OC and OA so that we will get two triangles here. Now come to prove it. From triangle AOE and triangle COF, we have OC is equal to OA. This is because they are the same radius of the circle. OF is equal to OE. It is been given here, and angle AEO is equal to angle CFO, and both of these angles are 90 degree. So to prove two triangles congruence, we have three conditions here. So we can say triangle AOE congruent to triangle COF. When this is the case, we can write that AE is equal to CF. If we multiply both sides by 2, we will get 2AE is equal to 2CF. Instead of 2AE, we can write AB, and instead of C2CF we can write CD, and this is because we know the perpendicular from the center bisects the chords, and this is our final proof. Now come to 2 theorem from exercise 8.1. It says two chords AB and AC of a circle subtend equal angles with the radius passing through A. Prove that AB is equal to AC. Suppose this is a circle with center O. If we join OA, then subtend with two equal angles like angle BAO is equal to angle CAO. When this is the case, that we have to prove that AB is equal to AC. Come to particular enunciation. Let ABC is a circle with radius O, where AB and AC are two chords. Join OA. Radius OA divides angle A with two equal angles. It is to be proved that AB is equal to AC. To get two triangles, we need to join OB and OC. Now come to prove it. From triangle AOB and triangle AOC, we have OB is equal to OC because they are the same radius of the circle. Second, we have angle BAO is equal to angle CAO. This is because from our drawing. Third, we have OA is equal to OA, and OA is the common sides of both triangles. So here we have three conditions to prove the congruence of both triangles. So as we know that when two triangles are congruent, then their similar side and angles will be equal. So we can write AB is equal to AC, and this is our final